Can you hear me now? Okay. So this evening we are going to kickstart the physical chemistry with the topic thermochemistry. Thermochemistry. Okay. Now, what is thermochemistry? Thermochemistry is an aspect of chemistry that deals with the heat changes that are accompanying a chemical reaction. Okay. Now, when we talk about the heat change that accompanying a chemical reaction, we need to focus on the system where the reaction is taking place. Now, what is a system? A system is the point under study. Whenever you are carrying out a chemical reaction, your focus is on the reaction taking place, whether there is a color change, whether it will be evolved in that particular reaction, or whether it will be absorbed during the chemical reaction. Now, a very good example of a system is an instance. Let me just relate it to you having hot pepper soup. I believe everybody knows what we refer to as hot pepper soup. Now, when you have hot pepper soup in a pot and you try to transfer the hot pepper soup into a plate, initially the plate was cold. When you transfer the hot pepper soup into the plate, it is transferred to the plate. So the plate tends to gain heat from the hot soup. Okay? So that implies that the hot soup is losing heat while the plate is gaining heat. When you introduce your spoon into the plate that contains the hot pepper soup, heat is transferred to the cold spoon as well. Okay? So that implies that there's always heat transfer between hot and cold body. The hot body will lose heat, while the cold body tends to what? Gain heat. Okay? So now, when you're talking about the system, when it loses heat to the surrounding. And when the system gains heat, it gains heat from the surrounding. So there is always heat gain or heat loss in what? The thermochemistry. So the study of the heat change is what referred to as what? Thermochemistry. Is that taken? Now, whenever you're talking about the system and the surrounding, these two components make up the universe. So the universe is made up of what? Universe is made up of two components. We have the system and we have the surrounding. Okay? So when the system is the reaction, our focus in every chemical reaction is the what? The system. So I call it what? The point under study. So every other part other than the system is known as the surrounding. Is that okay? If you are carrying out acid-base titration, inside the conical flask, you have the acid and base. So the components of the conical flask, which is the acid and base, is your system. Is that okay? So you are expecting a color change. While the conical flask, the laboratory where the experiment is carried out, is part of the what? The surrounding. So when the system loses heat, it loses heat to the surrounding. When the system gains heat, it gains heat from the surrounding. So heat lost to the surrounding, heat gained from the surrounding. I think that is very clear to everybody. So that's a summary of what we'll be talking about. So when there is heat gain, we say that when there is heat gain by the system, such process is called what? Endothermic process. When there is heat lost by the system to the surrounding, that implies that such reaction is what? Exothermic reaction. So if you are following, type endothermic and exothermic in the chart. If you're following, type exothermic and endothermic in the chat. If you can hear me, type exothermic and endothermic in the chat. Now, since we've been able to identify the kind of heat change that occur during a chemical reaction, then the heat of reaction itself is called enthalpy. It is called what? Enthalpy. Now, what is enthalpy? Before I define what enthalpy is, the enthalpy right here is a state function. What is a state function? A state function is a variable that depends on the initial and the final state of the system. Now, in physics, for instance, when we are talking about change in velocity, we do have what we call the final velocity and what? The initial velocity. So the change in velocity is dependent on what? The initial and the final states of the motion, okay? So since velocity is the change in velocity is dependent on the initial and final state, so you can call this a state function as well. Change in velocity is also what? A state function. So the enthalpy is denoted by what? Delta H, okay? So enthalpy of reaction has to do with what? The heat change that accompanying a chemical process at constant pressure. The heat change that accompanies a chemical process at constant pressure is what? The enthalpy. So now the enthalpy of reaction may be positive and the enthalpy of reaction may be what? Negative. If enthalpy is positive, we say the reaction is what? Endothermic. Okay, that's why I asked you to type endothermic. Endothermic, that means it is absorbed. It's absorbed. Okay? Now, if the enthalpy of reaction is negative, it implies that the reaction is what? Exothermic. Okay? Which implies that it is what? Is evolved. It evolved. We have it evolved for exothermic. Now, these two processes we need to consider when it occurs in a chemical reaction. Okay? Now, I'm going to come up with an illustration, which is what? The formation of ammonia. The formation of ammonia is what process? Can you type the process in the chat? Formation of ammonia. We have it right here. N2 gas plus H2 gas resulting in the formation of ammonia. Okay, when we balance the chemical equation, we are going to have what here? 3. Then we have what? 2 right here. So the equation is balanced. So this reaction is called what? What's the formation of ammonia called? What process? Can you type that in the chat? Formation of ammonia is called I hope you can see the board clearly. Someone said the light is dimming. Can you see the board clearly? Is it okay now? I hope you can see the board clearly now. Is it still dimming? I need your response. Is the lights okay now? So the formation of ammonia is called what process? I need your response so that we can move on. We still have organic class today. The process is called ABA process, okay? The process is called what? ABA process. Formation of ammonia is ABA process. So this one is ABA process. ABA process. Okay? So the value of the enthalpy of reaction right here is minus 92.2. The units for the enthalpy is kilojoule per mole. Okay? Enthalpy is measured in kilojoule per mole. Now, since the value of the enthalpy right here is negative, therefore, the ABA process is what? Exothermic reaction. Okay? Now, what if we have the reaction of carbon with hydrogen? Okay, carbon is in its solid state, hydrogen is a gas, okay, resulting in the formation of C2H2. This is a gas as well. So what's the compound right here? C2H2 is what compound? Is an organic compound, hydrocarbon compound. What is the name of this compound? C2H2. Can you type that in the chat? The value of enthalpy for this is plus 226.7 kilojoule per mole. Okay, so which implies that since the enthalpy of reaction is positive, then the reaction is what? Endothermic process, endothermic reaction. Is that taken? Now, what is the impact name of this compound? C2H2. What's the impact name of the compound? Yes, what is the impact name of that compound? C2H2. I hope we are not having issue with the visibility. Someone said ethylene. Ethylene is a general name for ethene. Okay? Ethylene is the general name for ethene, and this is not ethene. Ethene is C2H4. Okay? So the general name for ethene is ethylene. So what is the impact name of this compound? Someone said, how am I getting the value? Okay, it is an experimental value. So in an exam, you will be given that value. I will show you in our calculation. This is an experimental value. Okay, so it will be given in the exam. So I'm going to consider certain calculation from our existing question right here. So we have existing question that we are going to consider, and you will see how it is being determined experimentally. Okay, so this compound right here is ethine. So the reaction here is formation equation for what? Ethine. Is that taken? So ethine is not ethylene. Ethine is acetylene. The trivial name for ethine is acetylene. Okay, so right there we are having the process is what? ABA process. While this is the formation equation for the ethine, which is the same thing as acetylene. Okay. Now, from this expression, we've seen the equation for exothermic process and endothermic process. In your exam, you'll be asked to draw energy profile diagram for a given equation. So you need to check the value of what? the value of enthalpy in order to know which energy profile diagram is suitable. Okay, now I'm going to give a small sketch right here, and you will tell me the what it actually represents. I'm going to give a small sketch, and you will tell me what it represents. So I have something of this nature, okay, and I have another diagram right here. So if you are to attribute these the two sketches to a particular natural resources, okay, or to a particular environment, which of these two represents a dam and which one represents waterfall? Dam and waterfall. Is it diagram A or diagram B? We have diagram A, we have diagram B. Which one represents a dam? Which one represents a waterfall? We have little space for conservation of water here, and we have a wider space for conservation of water in diagram B. So which one is a dam? Which one is a waterfall? Can you type that in the chat? Can you type that in the chat? Which one represents a dam? Which one represents a waterfall between diagram A and B? Yes, Femi, A is waterfall. Ascend, solution. A is what? B is a dam. Okay. So can we proceed? Now, since we've been able to place these two, this one is waterfall, and this is what the dam. Okay. So diagram A represents waterfall and B represents a dam. This implies that diagram A, which is the waterfall, give what? It releases water easily, okay? So since the water is being released easily by what? Waterfall, we say it is an exothermic process. Now, the dam right here represents what? The endothermic process. So I'm going to give the energy profile diagram by actually considering the waterfall that we have here and the dam, okay? So can I clean the board now? So the energy profile diagram, I'm going to sketch it based on what we are having on the board. So since this is the waterfall, look at the diagram properly, and this is the dam. So I'm going to have similar representation for the energy profile diagram. So here is my first profile. Remember, the question says we should draw or sketch energy profile diagram for these two chemical equations. Okay, so we have another one right here. All right. Now, for the first one, which is the exothermic process, we have it as what? The waterfall. So I'm going to have little space right here, and water is released. Okay, this is waterfall. First diagram A. Then for the second one, I have a wider space for conservation of water. Then we have it like that. So we have little space for conservation. We have a wider space for conservation. For the waterfall, water is being released at the bottom of the cliff. While for the what? The dam, there is no bottom for the cliff here, okay? Now, we are going to have our energy right here. Energy in kilojoule per mole. And here is what? The reaction pathway. Reaction pathway. Take note of that reaction pathway. Okay. The same thing, the energy in kilojoule per mole. We have the reaction pathway. Reaction pathway. So for the first equation, we have the reactants right here. What are the two reactants? We have the nitrogen gas with what? Hydrogen. That's the reactant side. Then on the product side, we are having what? The formation of ammonia. What is the amount of hydrogen gas? Three. What is the amount of ammonia? We have 2. Okay. So the next thing we are expected to identify is the enthalpy of reaction. Now, this is the reactant right here. So this is the H reactant. That's the enthalpy of the reactant. And the product is right here. This is what? H what? Product. So the difference between enthalpy of the product and the enthalpy of the reactant is what? Enthalpy of reaction. So I have to show the difference right here. Okay, so delta H equals, what's the value? Minus 92.2 kilojoule per mole. Okay, unit is right here. So we are having the difference between enthalpy of the reactant product is what? Minus 92.2 kilojoule per mole. Are you following? Now we have the next one, which is the endothermic process. Okay, should I proceed? If you are getting it, type proceed. In the chat, drop proceed if you are getting it right. You can't hear me. Can you hear me clearly now? Can you hear me clearly now? If you can hear me, indicate in the chat if you can hear me. Can you hear me clearly? Okay, all right, proceed. Now from the second equation, we have the reactants right here, carbon and hydrogen. So I have carbon, okay, plus what? Hydrogen. Okay, so please, you have to create enough space for the reactant. Don't write it this way, carbon, then hydrogen down there. So you write it on the same line. So we have the product formed is C2H2. Okay, this equation is not balanced, so we have to put a coefficient of 2 right here for the carbon. So we are going to have the enthalpy of the reaction is what? Positive. Is that taken? Which implies that the products, enthalpy of the products is higher than the enthalpy of what? The reactant. So because the enthalpy of reaction is enthalpy of product minus reactant. So in this, the enthalpy of the product is higher than that of the reactant. So the reaction will be positive, okay? So the difference here, we're going to have delta H reaction is what? What's the value? For delta H reaction, we have plus 226.7. Okay. Now there are other features that we are expected to indicate on the energy profile diagram. Energy profile. Energy profile. So for the exothermic process here, this peak, okay, is called the activated complex. Activated complex. Okay. Then the space between the reactant level and the activated complex is what? Activation energy, EA. So the EA there is activation energy. So from the level where we have the reactant to the peak here is activation energy. Okay, make sure you check the level of the reactant to the peak. From the level of the reactant, here is the reactant to the peak. That's activation energy, EA. Then this peak is called what? the activated complex. Activated complex. Now, what is activation energy? EA. Activation energy. The activation energy, EA, is the minimum amount of energy required to overcome the energy barrier during a chemical reaction for product to be formed. Now, before a reactant can transform into products, there must be an activated complex formed here at the transition state. Okay? So if energy is not sufficient enough to overcome this complex, okay, the reaction will not result into product formation. So it is at this point, if the activation energy is sufficient enough to overcome this complex, that is when you have the product formed. So in an instance whereby you have a reaction whereby product is not formed easily, we tend to introduce a catalyst. So the so the function of a catalyst is to support activation energy in a reaction whereby it is. So the function of the catalyst is to support the activation energy in a reaction whereby it is insufficient for product formation. Okay, so we've been able to draw the energy profile diagram for these two chemical equations. Okay, so profile diagram clear? Type that in the chat if you've understood the process. Profile diagram clear? Type that in the chat. Assigned solution. I hope you can hear me clearly. You are free to ask your question. What about the diagram? Profile diagram clear? If the profile is well understood. Clear? Yes, I need more responses. Femi, clear? We have a lot to do. Yes, I need more responses. All right. Now, the next thing we need to talk about is the S law or S's law. In the exam, you may be asked to state S's law or S law. As the case may be, we have S law. Okay? Now, what is S law? Now, S law states that if a reaction can be represented by a series of other reactions, if a particular reaction can be represented by a series of other reactions, then the algebraic sum of the enthalpy of the individual step is equal to the what? The enthalpy of reaction. Okay? Now, a particular reaction, a chemical reaction, can be represented by series of other reactions. So by the time you add up the enthalpy of the series of the individual reactions together, it will be equal to the enthalpy of reaction. That is what the S law is all about. Now, can you type S law in the chat so that I can move on? Again, S law states that if a reaction can be represented by a series of other reactions, if a reaction can be represented by a series of other reactions, then the heat change for that reaction is the algebraic sum of the enthalpy change for individual steps. Okay? So enthalpy of reactions are said to be what? Additive. Now we have a question right here. I'm going to write the question. given the following. We have the first equation given right here is this H2 gas going to C2H2. So delta H formation for this is plus we have the delta H formation is plus 226.7 kilojoule per mole. Then the next one we have carbon plus oxygen gas resulting in CO2. The enthalpy of formation is minus 393.5 kilojoule. Then we have the third equation, hydrogen gas plus half oxygen gas resulting into H2O, okay, which is a liquid. The enthalpy of formation is given as minus 285.8. You know, I told you that the values will be given in the question. Then we have to calculate the heat of reaction. So we're given this equation, H2 gas plus 5/2 O2 going to 2CO2 plus H2O. Okay, so I hope you can see the question properly. We're given three equations, okay? Yes, Femi, I can see the S law of constant heat summation. That's correct. That's S law of constant heat summation. It's different from S law. Is that taken? Yes, can I come up again with the activation energy? All right. I said activation energy is the minimum amount of energy required to overcome the energy barrier during a chemical reaction for products to be formed. Okay, so the activation energy is the amount of energy, minimum amount of energy. That expression must be there. Minimum amount of energy required to overcome the energy barrier. The energy barrier is the activated complex. Okay, so if you are asked to define activated complex, the activated complex is the barrier that must be overcome during a chemical reaction for product to be formed. Okay, so that is activated complex. Why the energy is the minimum amount of energy that is required to overcome the energy barrier. So now we are to consider these individual equations right here. I hope you can see the board clearly. Can you see the equations? Can you see the equation right there? All right, I think it's clear. So we were given three equations. We have three equations, and we are to determine the heat of reaction, delta H reaction. I hope you are with your calculator because I don't have a calculator right here. Calculator available, can you drop that in the chat? If you have your calculator, so you will help me with the calculation. Is calculator available? Do you have calculator? You help me with the calculation as we proceed. Yes, okay. All right. Now we have the individual reaction. I have equation 1, so we can identify this as equation 1. Please identify this as equation 1. Identify this as equation 2. And this is what? Equation 3. Now, this aspect of chemistry is similar to this particular game that we play, puzzle game. So you are going to rearrange the three equations such that it will be the same as the overall equation right here. Okay? So we are going to rearrange this equation so that it will be the same as this overall equation. So can we do that together? So you're going to help me out in playing this puzzle. So we need to play the puzzle right here. All right, let's start. Now, we can look closely at the overall equation. I have the ethane on the reactant side and oxygen 5/2 mole of oxygen on the reactant side. Then we have 2 moles of what? The CO2, and the coefficient of water is 1 on the product side. So in the first equation, you can observe that the ethane is on the product side, and we need the ethane on the reactant side. That implies that I will need to reverse this equation. So can I write rearrange equation 1? Okay, so when we rearrange equation 1, so I will bring this to the other side. It will be C2H2 going to what? 2C solid plus H2 gas. Okay, I've been able to reverse the equation. Therefore, it will affect the sign of enthalpy of formation of the ethane. So if the sign is positive initially, it will change to negative when you reverse the equation. Okay, so we are going to have enthalpy of formation is now what? Negative. Negative what? 226.7 kilojoule. Make sense? If you've gotten that, type make sense in the chat. If what I did there is well understood, type make sense. If it is well understood, we reverse the equation. So it definitely it's affected the sign of enthalpy. Type makes sense. And if you do not get it right, then you indicate in the chat. All right, makes sense. So we can proceed. Can we move to the next equation right here? The equation 2. We need CO2 on the product side. Okay, we are still playing the puzzle. We need CO2 on the product side. And right in this equation, we have the CO2 on the product side. But you can see that the coefficient of CO2 in the overall equation is 2. And the coefficient right here is what? Is 1. So there is need for us to multiply this equation right here by what? 2. So multiply equation 2 by what? 2. Okay, so we multiply equation 2 by 2. So what do we have? 2C, that's carbon, plus 2O2, that's oxygen, resulting in what? 2CO2. Definitely, since we've multiplied the equation by 2, we are going to multiply the enthalpy of formation by 2 as well. So can you help me to press the calculator? Minus 393.5 times 2. 393.5 times 2. What's the value? 393.5 times 2. minus 787. Is that confirmed? Yes, can someone confirm that? Yes, 787. Okay, minus 787. So we have delta H formation is minus. Okay, we still retain the minus since we did not reverse the equation. Minus 787 kilojoule. Okay, now let's proceed. This third equation, don't disturb now. Now, this third equation, we need water on the product side. So it is on the product side, right? So we do not need anything. We don't need to multiply since the coefficient of water is 1. And right here, the coefficient of water is 1. So let's have it. H2 gas plus half O2 gas, resulting in what? Formation of water. Then the enthalpy of formation is what? We are having minus 2.8 what? 5.8 kilojoule. Okay? So we are going to confirm if on adding, according to S law, when we add the individual enthalpy for the reactions right here, it must result into what? Enthalpy of reaction. So addition of the enthalpy of the individual step must give what? Enthalpy of reaction. So if we don't have the overall equation, then we cannot add it up. Okay? Let us get the overall equation. Now the overall equation, right here, we need to add all the, that we have on the reactant side. We're having C2H2. C2H2. That's the ethane. Then I'm having 2 carbons right here. Then on the product side, we have 2 carbons. So can I remove this? Okay, this will cut this out. Is that clear? Then we are having oxygen here. I'm having hydrogen right here. The hydrogen here will cancel the hydrogen molecule there. So we are left with oxygen. Can you help me to add this? I'm having 2 as the coefficient of oxygen right here, and I'm having half as the coefficient of oxygen right here. 2 plus half. That's 2.5. 2 whole number 1/2. Is that correct? No, it's not. That's not correct. That will give us 5/2. Okay. Is this still the same thing? The LCM is 2. Now 1 into 2, 2 times 2, 4. Plus 2 into 1, 1 times 1, 1. So that's 5/2. We have 5/2 O2 going to, we are done with the reactant side. Then the next thing, do we have any product particle right here? No. We are left with 2 CO2 here, 2 CO2 plus water, H2O. Okay? Can we compare this equation that we've gotten on adding the equation for the individual step together? Let's compare it with the equation given. Do we have any similarity in this equation? Is there any similarity between this equation? It is exactly the same thing. Okay, so since this equation, on adding all these equations together, we have the overall equation as this. Okay, then we can add all the enthalpy together. So delta H reaction equals, we have minus 226.7 minus 787 minus 285.8 equals what? Okay, that is what the Hess law states. That's the enthalpy of what individual step, when you add it together, it must give you enthalpy of reaction. Okay, so what is the final answer? Can you type that in the chat? Yes, it is the same. Yes, Femi, where did you get minus 1,299? Is that the final answer? What is the final answer? Please confirm that answer. Is that the final answer? Femi, is that the final answer? Minus 1,299.5. All right, it is correct. Minus 1,299.5. So we have minus 1,299.5 kilojoule per mole. Okay, so I believe we have Yoruba guys there. When they say kilojoule, what I expect to say? Inalojo abi. So kilojoule per mole is the unit of what? The enthalpy right here. So we've been able to justify this by following what? S law or S's law, okay? If you are following, type I'm following. If you are following, type I'm following. Now, when you see any question, you are likely, we've seen several JUPEB past questions whereby they ask question on the S law calculation like this. So I call it a puzzle. Are you getting it? It is the additive of the enthalpy of individual step that result into the overall equation, okay? So additive of enthalpy is what? S law. Is that taken? So the next thing we need to consider is the law of thermodynamics. Okay, we are now on thermodynamics. We are going to consider the first law of the thermodynamics. The first law states that what? I think everybody actually knows that. First law of thermodynamics states that energy can neither be created nor destroyed, but can be transformed from one form to another, okay? Which implies that when a system gains heat, it actually gains such heat from the surrounding. And when the system loses heat, it loses the heat to the surrounding. So heat gain and heat loss remains constant in any chemical what? Reaction. So I can equally say that when a system gains or loses heat, the total energy will be constant. When a system gains or loses heat, the total energy is what? Is constant. Now, we have an expression for the internal energy. The internal energy, in some cases, we have internal energy as E, and in some cases, we have the internal energy as U. So it depends on what the question is all about. So permit me to denote the internal energy as E. So change in internal energy is what? The change in quantity of heat plus what? Work. Now, the work done right here has to do with what? The gas components. For instance, if the system is made up of gas or gaseous what? Particle, that implies that we need to consider what? Expansion or compression of gas in a piston. So let me have this as my piston. So I have a piston right here, okay, just like a syringe. If we are having gases inside the piston right here, it implies that the gas component in the piston is the system. Okay? The piston itself is the surrounding. So it is possible for the gas to exert pressure on the wall of its container. You know, gases are free to move, to collide with each other on the wall of the container. And the collision is said to be what? Perfectly what? Elastic. Now, when the gas component in this container pushes the piston, when the gas push the piston outward, we tend to say that the system is doing work against the surrounding. So when the system does work against the surrounding, it implies that the system is losing energy. Okay? So for work done by the system against the surrounding, W will be what? Negative. Work done by the system against the surrounding. So that means it results into expansion. So expansion of gas has what? Negative work done. Is that okay? Now the compression, this for expansion. Work done is what? Negative for expansion. But for compression, okay, work done is what? Positive. Because the piston is doing work against the system, on the system. When the piston, which is the surrounding, does work on the system, we say we are going to have what? Compression. It's just like you are pushing something downward. Then the system tends to gain more energy. Okay? So since the system is being acted upon by the surrounding, there is what? Gain of what? Energy by the system. So the work done is what? Positive. Is that okay? Now, we have the expression for pressure volume work done. You know, pressure is exerted on the volume of gas. So for pressure volume work done, when we have expansion, note this, we have P change in what? V, volume will change. Okay, pressure remains constant. Now, this for expansion. For compression, the pressure volume work done is what? Positive, change in V. Here's another formula, okay? So in place of the work here, I can substitute what? Pressure volume. Okay, delta Q plus what? For the compression, I have, for the expansion, I have W right here, okay? Then, I have P change in V. P change in V, okay? From ideal gas equation, we all know that for an ideal gas, PV equals what? nRT. For an ideal gas, okay, the gas in the piston behave ideally, right? So we have PV equals nRT, okay? So what will be the expression for P change in V? For P change in V, we have change in what? nRT, okay? So the expression right there becomes change in internal energy equals change in quantity of heat, then we have nRT. Okay, I can substitute nRT in place of what? P change in V. If you are okay with this, type okay. If you are okay with the expression there, type okay. I hope I'm not too fast. Are you okay with my explanation? Are you okay with the explanation there? So we can take a question. Type okay if you're okay with the explanation. All right. So we are going to consider a question right here on this. And you tell me which formula is suitable. We have a system A system expands from an initial volume of 1.0 dm cube, okay, 1.0 meter cube, sorry, meter cube, to 4.5 meter cube against a pressure of 1.2 times 10 raised to power 4 Pascal. What is the work done? Work done by the system. Now there is an answer in the question itself, okay? What is the work done by the system? So work done by the system, what is the sign of W? Is it positive or negative? Work done by the system. Can you type that in the chat? Positive or negative? Work done by the system. What will be the sign of the work done? Positive or negative? Work done by the system. Positive or negative? Yes, that's negative, okay? Negative. So, work done by the system against the surrounding, that is expansion. So, the work done is negative, right? So, we have change in volume and we were given the pressure exerted. Is that okay? So, which formula is suitable? W equals negative what? P change in what? V. Is that okay? So we are going to have a negative value there. Is that okay? Now, we are having initial volume as what? 1.0 and the final volume is what? 4.5. So we are going to adopt the general expression of P change in V. So it is in the final answer that this negative will appear. Okay? So we are having the pressure 1.2 times 10 raised to power what? 10 raised to power what? 4. Okay? Open bracket. The final volume is what? 4.5 minus 1. So we have W equals minus 1.2 times 10 raised to power 4 times 3.5. So what's the final answer? 1.2 times 10 raised to power 4 times 3.5. What's the answer? Yes, what's the answer? Can you press your calculator? Femi, work done by the system is negative. Okay? Work done on the system by the surrounding is positive. So the answer is not positive. So can you type the answer? What is the answer? 1.2 times 10 raised to power 4 times 3.5. Help me with the answer. Do we have 4,200? Are you sure it is 4,200? No, it shouldn't be. Please check the answer. I'm suspecting 4.2 times 10 raised to power 4. $42,000. I think that's correct. 42,000. 42,000 is the same as what? Minus 4.2 times 10 raised to power 4. Okay. What's the unit of work? The unit of work is what? Joule. Okay, is that clear? I hope that is clear. Minus 4.2 times 10 raised to power 4 joule. Is that taken? So we have another question right here. We have another question. So after thermodynamics, we are going to consider solubility products. Okay. So we have another question. What is the standard enthalpy of formation of ethene? Ethene has the molecular formula C2H4. If the standard enthalpy of combustion, we've talked about combustion today, combustion is minus 1411, that's 1411 kilojoule per mole. So the question is, what is the standard enthalpy of formation of ethene, given that the enthalpy of combustion is what? Minus 1411. Okay. Now, from this particular question, we are expected to understand that enthalpy of formation, please note this, enthalpy of formation, standard enthalpy of formation of an element, I have elements in brackets, standard enthalpy of formation of an element. It's not possible for you to form an element, okay? So there is no component that will combine to give an element. So the standard enthalpy of formation of an element is equal to 0. Take note of that. The standard enthalpy of formation of an element is equal to 0. Can we write the combustion equation for this process? We have, for the ethene, C2H4 plus oxygen results in the formation of CO2 plus what? H2O. Okay, so that's the combustion reaction for the ethene. Now, is the equation balanced? We have 2 carbons right here. In my video lesson yesterday, I explained the general combustion equation for those people that attended. So I have 2 carbon atoms right there. Then here we have 4 hydrogen. Can I put 2 here as the coefficient of water? Then the next thing is we have 4 oxygen atoms here and 2 oxygen, making 6. So what is the coefficient of oxygen here? We are going to have what? 3. 3 times 2, 6. Okay. Now the next thing we are expected to do is to write the expression for the enthalpy of what? Reaction, based on the equation right here. Now, enthalpy of reaction is generally written as the standard enthalpy of reaction. We have summation N delta H formation of what? The products, minus summation M delta H formation of what? The reactants. Okay, so note this, standard enthalpy of reaction equals summation of enthalpy of formation of the product minus summation of enthalpy of formation of the reactants. So I'm going to express this now. We have delta H reaction equals, what are the products? We have 2 delta H formation of what? CO2. Okay, the 2 right here is the value of N for CO2, the coefficients. Okay, summation plus 2 delta H formation of what? Water. That's H2O. Okay. Minus the reactants. Delta H formation of what? The ethene plus what? That of oxygen gas. Oxygen right here is an element. So enthalpy of formation of an element is equal to 0. So I will end it there. So I'm expected to write plus oxygen. Okay. So enthalpy of formation of an element. The element right there is what? Oxygen. Okay. Okay. So we don't have combination of atom there. So do we have the enthalpy of formation of CO2? We are expected to have that in the question. Let me check. So we're given in the question enthalpy of formation of CO2. Given in the question CO2 as minus 394 kilojoule per mole. And also we're given the enthalpy of formation of water, H2O, as minus 286 kilojoule per mole. Okay, so we can substitute all those values there. Then we have the expression right here. In the question, we have enthalpy of reaction as what? Minus 141. I hope you can hear me. If you can hear me, type I can hear you. Can you hear me? Someone typed which country? This is happening in Nigeria. Okay, you can hear me. So we have the standard enthalpy of combustion is what? Minus 1411. That's it right here. Okay, it implies that this negative shows that the overall reaction is what? Exothermic because of the negative value. Then we have 2 times the enthalpy of formation of CO2. So we have 2 times, what's the value of the enthalpy of formation of CO2? Minus 394. Okay, we are going to have that. Let me put it in a bracket here. Plus, we have the water molecule right here. What's the enthalpy of formation of water? Minus 286. So I'm going to have the coefficient of water is 2 as well. So 2 times minus 286. Okay? Minus the enthalpy of formation of ethene. That is the unknown. We do not know the enthalpy of formation of ethene. So we are to find the enthalpy of formation of what? Ethene. Okay? So can you help me to press this? 2 times minus 394. Then 2 times minus 286. We had the value, the final value for this together. So 2 times minus 394 plus 2 times minus 286. Drop that in the chat. 2 times minus 394 plus 2 times minus 286. The sum is what? I can see minus 788. Is that the right answer? Please, I need you to confirm the answer for me. I hope you can hear me now. Can you hear me now? Can you hear me now? I believe you should hear me now. I've changed the microphone. Please confirm this. Can you hear me now? All right, on adding this together, we have minus 1,360, okay? So when we make the enthalpy of formation of ethene the subject of the equation, we are going to have this, okay? So all we need to do is to add this, minus 1,360 plus 1,411 minus, so what do we have? Minus 1,360 plus 1,411. What's the final answer? What is the final answer? Can you press your calculator? What is the final answer? I need your response. What is the answer to this question? Someone is having plus 51. Okay, so we have our answer as what? Plus 51. So you have to indicate the sign, okay? Plus 51 kilojoule per mole. All right, so that is the enthalpy of formation of what? Ethene. Now, if you are to write the formation equation for ethene, you may be asked to write the formation equation for ethene and you attach the value to it. For us to have ethene, what are the elemental components that gives what? The C2H4. We have carbon. The first element that we can see in this compound is carbon plus hydrogen. Hydrogen cannot be expressed as H, but what? H2. Is that okay? Resulting in the formation of C2H4. Is that taken? So we have two carbons right here, so I need to put 2. I'm trying to come up with the formation equation. Then we have 4 hydrogen atoms here, so there is need for us to put 2 here. So the equation is balanced. Then I'll write delta H formation equals plus 51 kilojoule per mole. Make sense? So this is the formation equation for what? The ethene. Is that taken? If that is clear, type clear. So I've been able to express the formation equation for ethene. If that is clear, type clear. If that is clear, type clear. If that is clear, type clear. I need your response so that we can move on. So when we are done with this physical chemistry, we are going to have like 30-minute break before we continue with organic. We need to end what we started yesterday. All right, clear. So the next thing we need to consider is the second law of thermodynamics. Second law of thermodynamics states that the reaction, the spontaneous change occurs in the direction in which there is an increase in total entropy of a reaction. I repeat that. A spontaneous change occurs in the direction in which there is an increase in total entropy of a system. A spontaneous change occurs in the direction where there is an increase in the total entropy of the system. Now, let us consider the spontaneity of reaction. We are on entropy now. Entropy. Entropy is denoted as delta S, entropy change, delta S. Is that okay? Now, what are the states of matter? We have the solid, liquid, and gas. We have solid, liquid, and what? Gas. Okay? So let's consider these three states of matter. When we move from solid to gas, we say there's what? An increase in entropy. What is entropy? Entropy is the degree, or let's say it is the measure of the degree of randomness or disorderliness of a system. The measure of the degree of randomness or disorderliness of a system. So disorderliness is highest in gas, okay? And it is least in solid. So if we move in this direction from solid to gas, that is what? An increase in entropy. So the degree of disorderliness increases from solid to gas. So this is the increasing order of entropy. Increasing what? Entropy. Okay? Now, you are given an equation, let's say Haber process, and you've been asked to show if entropy increases or decreases in an equation. I have hydrogen gas resulting into ammonia. Gas. So from this expression now, we can see that the components of the reactants are both gases, while the product particle right here is also a gas. So we need to check the coefficients. We have the coefficient of hydrogen gas is 3 right here, while the coefficient of ammonia right here is 2. We have a balanced equation. So what is the amount of gaseous reactant here? We have 1 mole plus 3 mole. We have 4 mole of gas on the reactant side, while on the product side, we have the coefficient as 2. So we have 2 mole of gas on the what? Product side. So 4 mole of gas results into what? 2 mole of gas. Is this an increase or decrease in entropy? 4 mole of gas formed 2 mole of gas. Type in the chat, is it an increase in entropy or decrease in entropy? Visionary, you need more explanation on what? All right, assigned solution. I should be slow with my explanation. No problem. We have a lot to cover. I know you are very much ready for this class. So even if we can take it till done, the most important thing is for you to have A in chemistry. Yes, can you respond to that question? I have 4 moles of gas on the reactant side, resulting into 2 moles of gas on the product side. Okay? So is that an increase or decrease in entropy? Indicate in the charts. Do we have an increase or decrease in entropy in Haber process right there? You don't need the value to denote whether there's an increase or decrease. Yes, Precious said decrease. We have decrease in entropy, yes. Visionary, decrease in entropy. Ascent solution, decrease in entropy. Yes, 4 mole of gas to 2 mole of gas shows what? There is a what? Decrease in entropy. There is a decrease in entropy. Okay? So we need to, please kindly take note of this equation right here. I'm going to give you an expression that you are going to use anytime you are to calculate anything on entropy. We have lots of questions on entropy from JUPEB. Okay? It comes in different forms. So, for the entropy of reaction, standard entropy of reaction, you can as well use the expression summation of N delta S of products minus summation M delta S of reactants. Okay? But note that standard entropy of an element in brackets here, standard entropy of elements is not equal to 0. Okay? But in enthalpy, delta H, standard enthalpy of an element is equal to 0. But for entropy, standard entropy of an element is not equal to 0. So there is a value for the entropy of an element. So you will be given the value for the entropy of an element. Okay? Now we have an expression for the entropy. I have delta S surrounding is equal to delta H system. Okay, this enthalpy of a system over the temperature of the surrounding. So entropy of the surrounding equals enthalpy of the system over the temperature of what? The surrounding. Recall that when we started, I explained that the universe is made up of 2 components. That's the system and the surrounding. So since the universe is made up of system and surrounding, so the entropy of the universe, okay, permit me to have universe as uni there, equals delta S system, okay, that's the entropy of the system, plus delta S surrounding. Is that okay? So the addition of system with surrounding gives what? The universe. Is that taken? How will I get the enthalpy of the system? Enthalpy of system is also the same thing as enthalpy of reaction. So how will I get enthalpy of the system? We have the expression right here. Okay? So you're going to make use of this expression. Summation of delta H formation of the product minus summation of delta H formation of the reactants. So you're going to use that formula. There's another case whereby you may not be given this expression, but you can use this formula as well. We have the NC change in what? Temperature. Is that okay? We can have this one as Cp. So the expression right here has to do with what? The specific heat what? Specific heat what? Capacity. Is that okay? That's specific heat capacity. So this one is specific heat capacity. So if you are dealing with water, the specific heat capacity of water will be given. This is the number of mole. You can use the expression from the mole concept, reacting mass over molar mass, to determine number of mole. and this is the change in what? Temperature. So I'm going to give you a question right now. Please, if you are okay to this level, type okay in the chat. If you are okay, yes, Shurakat said, why, sir? Can I know why you are having such question? Why, sir? Why to what? So if you are okay with the expression on the board, type okay. What's another? That implies we can actually proceed. Okay? So we have a question right here. Let's take this question. Please note this formula. Enthalpy of reaction equals summation of N delta H formation of the product minus that of what? The reactants. We have a question. Check your knowledge. That's my CYK there. Check your knowledge. Calculate the amount of heat absorbed when 48 grams of water. Let me change this marker. 48 grams of water is heated from 30 degrees Celsius to 95 degrees Celsius. Given that specific heat capacity, its capacity of water is what? 4.2. That is a constant. Already we know that from secondary school. Kilojoule per mole at constant pressure. Okay, pressure. All right. Now, how do we determine the amount of heat? So the amount of heat is talking about what? The enthalpy right here. So we have to determine the enthalpy. So this is the formula to use. Okay, we have to find the enthalpy. So since we have the reacting mass right here, what is the molar mass of water? Can you type that in the chat? What is the molar mass of water? Yes. Visionary, what is your message? Sorry, I'm the only one here. There's no one to check the comment for me. Yes, Precious, the molar mass of water is 18. That's right. Yes, Visionary, which parts are you finding difficult? Which parts? You have to be specific. Which parts? Which parts are you finding difficult? You need to specify which part. I hope the part is still on the board. All right. We have the number of mole, the solution now. The number of mole is what? Reacting mass over molar mass. So the reacting mass is what? 48. The molar mass of water is 18. Okay, how did we arrive at 18? We have the atomic mass of hydrogen is 1. 1 times 2, we have 2. Then plus atomic mass of oxygen is 16. So 2 plus 16 is 18. That's how we got 18. What is 48 over 18? Drop that in the chat. 48 over 18. The last part, are you talking about the entropy part? Visionary. Yes, what is 48 over 18? You keep saying the last part. Is it the aspects of entropy? Are you talking about the entropy? How we deduce that there is a decrease in entropy from 4 moles to 2 moles? What is 48 over 18? Can you confirm that answer? 2.66? Oh, sorry about that, visionary. Sorry about that. 2.67, 2.66. So, what is the answer? 2.66, 2.67? Which one is correct? All right, we go with 2.67. 2.67 mole. Okay, so I have the number of mole. Then the specific heat capacity is 4.2 kilojoule. Is that taken? 4.2 kilojoule. Then we have the change in temperature. The change in temperature is right there. So all we need to do now is we have delta H equals, we have the number of moles 2.67 times, we have to express the specific heat capacity in joule per mole. Okay, then we can convert the final answer to kilojoule. So when you multiply this by 1000, we have 4200. Am I correct? 4200 times, what is the change in temperature? We are having 95 minus 30. I hope you can see this lower part of the board. So we are having delta H equals 2.67. Sorry, can you multiply this? This will result to, that's 65. We're having 65 times this. Get the answer for me. 65 times this product. What's the final answer? What is the final answer? Do we have 11,214? Please confirm that answer. Wow. This is another one of those. 616,770. Confirm the answer, please. We have 13 participants, 14 participants at the moment. Confirm the answer. I'm seeing another one from Freshy. 728,000. Now, visionary, please kindly continue on CYK now. Concentrate on the CYK, the one we are dealing with, okay? So that you don't lose focus. Concentrate on what we are doing now. Yes, I'm having different answers. 728,910. Please confirm the answer so that we don't proceed with a wrong answer. I think the final answer is 728,910. Okay, 728,910. So when you multiply this, we have 728,910. Okay, 728,910 joule per mole. Okay, joule per mole. So when we divide by 1000, we are going to have 728.9 kilojoule per mole. So we can have our final answer in kilojoule per mole now. 728.9 kilojoule per mole. So that's the final answer for the enthalpy. Okay, or also known as the amount of heat absorbed. Why is it that we are having a positive value right here? Assuming it has been stated in the question that heat evolved, that implies that the initial temperature will be 95. Okay, it implies that initial temperature will be 95 and the final temperature will be 30. That is if the heat is evolved. Okay, since heat is absorbed, the final value of enthalpy will be what? Positive. So that is the correct answer to this question. Make sense? Can you do that? Type make sense in the chat so that we can proceed. Make sense? We're almost done with this part. We are on entropy now. All right, makes sense. Now, the next question we are going to take is very essential for JUPEB exam. The next one we are going to take is very essential for JUPEB exam. Okay? So, I would like you to, within the space of 2 minutes, try and invite other friends to join this live class. Okay? Try and invite other friends to join this live class because we're almost ending the physical aspect of the first part of our physical chemistry. Invite friends to join this live class. Then a student called yesterday that they wish to support the movements. If you wish to support the movements, okay, I can drop my account number here. So if you are willing to support the movements, type support movements. So I will drop my account number. Then you can support the movements for more classes. If you wish to support the movements, support, support, support. And if there is no support, we proceed. No support. All right. We are moving to the next part, which is the essential part. The essential part. So the next question we are going to consider right here has to do with the combination of the entropy as well as the enthalpy. Okay? So I should not drop my account number, Abi. So that we'll go and sleep now. You know, practical chemistry is still on the way. I should go and sleep. All right. Can we take this question? Please, I would like you to be very observant and attentive in this particular question, okay? So that you won't be missing in the action right here. So we have to calculate the change in entropy of the universe for the following process at 310 Kelvin. We're given the equation CO plus 2H2 gas going to CH3OH. That's liquid. Don't be scared of table. This is very simple question. It's a very simple question. CH3OH. We have delta H formation in kilojoule per mole. We have delta S in joule per mole. Please note this. The entropy is in joule per mole per Kelvin. Entropy is in joule per mole per Kelvin. 110.5, 198, 0, 131, minus 239, 127. Okay? So you are expected to copy the table before we proceed. Share this live class with your friends so that we can have them on board as well. Share this live class with your friends so that we can have them online. Can we proceed? Do you have the question now? When you are set, indicate in the chat. When you are set, indicate in the chat. Are you set? Can we proceed? All right, I can see continue. We can proceed. All right. All right, we are going to look at the table together. Now, I hope you can see in the chat, that is my account number. That is my account number. Okay, for those of you that you wish to support, that is the account number. So we proceed with the class. Now, can we look at the table closely? We've been asked to determine the entropy of the universe. Okay, and in order to get the entropy of universe, we need to determine the entropy of the system as well as the entropy of what? The surrounding. Okay, so in the question, do we know the entropy of the system? Can we check? No. So we need to find the entropy of the system. Do we know the entropy of the surrounding? No. We need to determine the entropy of the surrounding in order to get this particular question. Entropy of the system and as well as the entropy of the surrounding. In order to get the entropy of the surrounding, we need to find the enthalpy of the system. Then the temperature of the surrounding is known. Here is the temperature of the surrounding. That's the T surrounding. Okay, we know the T surrounding right here. We need to find the enthalpy. So this particular question has babies. Okay, so the question we are having entropy of. So making how many unknowns? We have what? 3 unknown. 1, 2, 3. Okay. So if we know the enthalpy of the reaction, also known as the enthalpy of the system, we can find the entropy of the surrounding. Then from this information right here, we can use this formula, okay? Delta S reaction to find entropy of reaction. Is that taken? We have the values for the reactants as well as the products. If you're okay with this, type clear, okay? If you're okay with the explanation, type clear so that I can proceed. Type clear if you're okay with the explanation. All right, clear from Precious. For those of you that you are just joining us, make sure you subscribe to this channel so that you can always receive notification. And for those that are transferring something to the account number sent, you can as well WhatsApp me on that number. If you did not transfer, don't WhatsApp on that number. So you send the evidence of your transfer, okay? Then we have further discussion from there. If you are making transfer, make sure you send the evidence of transfer, okay? The transaction to me on WhatsApp. Then we have further discussion from there. Can we proceed? We have to find the entropy of the system, entropy of the surrounding, as well as the enthalpy of reaction, which is the same thing as enthalpy of the system. Can I proceed? Just type proceed. Type proceed. Visionary, I hope I can proceed this time around. Can I proceed? We have to find, I know some students, they've started the calculation already. Can we proceed? Please, we have to be fast. Can we proceed? Normally, we expect to start the next class by 11:30. This 11:07 already. Can we proceed? All right, proceed. So take note of the formula right here. We are going to make use of those formula. All right. So let's start with where should we start from? Let's find the entropy of the system, which is the same thing as entropy of reaction. So we have delta S reaction equals summation N delta S of products minus summation M delta S of what? The reactants. So here is the product side and this is the reactant side. Okay, so let me extract the components of the product as well as the reactant from the equation. I have delta S reaction equals the product right here. There's no coefficient, so we have delta S of what? CH3OH. That's methanol. That's the only product that we are having here, minus the reactants. The first reactant there is what? CO2. We're having CO plus delta S of what? We have a coefficient there, so it will be 2 delta S. Okay, 2 delta S of hydrogen. Is that taken? So from here, we can substitute the value of what? The entropy. Delta S reaction equals, what is the entropy of the methanol right here? Entropy. That's what? We're having 127. Okay? That's the only product. Then what is the entropy of CO2? CO, carbon monoxide, CO? 190 what? 8 plus, what is the entropy of hydrogen gas? We have 2 times what? 131. Okay? So from here we have delta S reaction equals 127 minus 2 times 131 is what? That is 262. Please confirm that. 262 plus 198. 262 plus 198. What is the answer? 262 plus 198. Two 62 plus 198. Drop the answer. Do we have 460? We have 460. 262 plus 198. Please, I need your response. Two 62 plus 198. Please, you have to respond so fast so that we can proceed. Visionary, I can see your message, okay? Make sure you are stable on this live class. Make sure you are stable. What is the answer? One 198 plus 262. You have 460. So 198 plus 262, we have 460. Okay. So delta S reaction equals, so what is the final answer? Do we have 333 minus 333? What is the unit of the entropy? The entropy is joule per mole per Kelvin. So we have joule per mole per Kelvin. Okay, that is the unit of entropy. So we've been able to get the entropy of the reaction. Now, can we proceed to determine the entropy? We can't get the entropy of the surrounding yet, since in order to determine the entropy of surrounding, we need to find the enthalpy of the system. So let us get the enthalpy of the system. We have delta H reaction, which is the same thing as that of the system, equals summation N delta H formation of what? The products, minus summation M delta H formation of what? The reactants. Okay? So we have enthalpy of reaction equals, so the enthalpy of the products is what? The methanol right here. So I have minus 239 minus the sum of the enthalpy of the reactant. The enthalpy of CO is minus 110.5 times, plus minus 110.5 plus the enthalpy of formation of hydrogen gas right here. This is an element. The enthalpy of formation of an element is equal to 0. That's 2 times 0. Okay? So we are going to have delta H reaction equals minus 239 minus times minus, that's plus 110.5. Okay? So what is the final answer? Can you drop that in the chat? Minus 239 plus 110.5. Drop the answer in the chat. Drop the answer in the chat. So what is the final answer? Do we have minus 349.5? We have minus 349.5. Please confirm the answer. Ascend. Okay. Please confirm the answer. Confirm our answer, please. Minus 128.5. Is that the correct answer? Yes, okay. Minus 128.5. Minus 128.5. So we have, so when you add this together, you have minus 128.5. What is the unit of the enthalpy? We have kilojoule per what? Per mole. Is that taken? So we have the value for the enthalpy of reaction. We can now determine the entropy of the surrounding. So delta S surrounding equals delta H reaction, which is the same thing as that of the system, over T surrounding. Note that the entropy right here is in joule. So we have to change the enthalpy from kilojoule to joule. By doing what? We have to multiply by 1000, okay? So when you multiply this by 1000, we are going to have minus 128.5 times 1000 in order to convert to what? Joule per mole, divided by the enthalpy, the temperature of the surrounding right here is 310 Kelvin. 310 Kelvin is the temperature. So can we have minus 1.285 times 10 raised to power, that's 5, divided by 310. What's the final answer? Drop that in the chat. What is the final answer? What is the final answer? Please confirm that answer. From Precious, minus 14.516. Confirm the answer, please. Minus 414.5. Is that the final answer? Minus 414.5. Make sure you share this live class with your friends. Let us confirm the answer. Minus 414.5. Is that the final answer? All right. So we can proceed. Minus. So delta S surrounding equals minus 414.5. What is the unit? Joule per Kelvin per mole. That's the unit of what? Entropy. Okay. So what are we expected to do now in order to get the entropy of the universe? We need to add the entropy of the system with that of the surrounding. Let me just have it here. What is the entropy of the system? The entropy of the system is minus, can I erase this? The entropy of the system, so we have to find the entropy of the universe. Entropy of the system is what? Minus 333, that's 333, plus what is the entropy of the surrounding? Minus 1, sorry. What is the entropy of the surrounding? We have minus 414.5. So can you subtract this? Minus 333 minus 414.5. What is the final answer? Yes, minus 330 minus 414.5. What is the final answer? What is the final answer? Minus 747.5. That's from Ascend. Can you confirm the answer? Minus 747. Please confirm the answer. Confirm the final answer. Is that correct? Minus 7. Okay, that's confirmed. Minus 747.5. So we have minus 747.5. What will be the units? The unit is what? Joule per Kelvin per mole. Okay, so we've been able to determine the entropy of the universe we've been able to determine the entropy of the universe by adding the entropy of the system with that of the surrounding. Makes sense? If you've gotten this right, type makes sense. If that is clear, type makes sense. If that is clear, type makes sense. If that is clear, type makes sense. Okay, sharp. I like that from Ascend. So we are going to end the thermochemistry with the third law of thermodynamics. And the third law of thermodynamics has to do with perfect crystalline solid. Okay? So the third law of thermodynamics states that the entropy change of all perfect crystalline solid is 0 at 0 what? Can you complete that for me? At absolute 0 what? Temperature. Okay? The third law of thermodynamics states that the entropy change of all perfect crystalline solid is 0 at absolute 0 what? Temperature. Okay? Absolute 0 temperature. Now, what are we trying to say right here? I hope I can clean this off. Can I clean this? The entropy change of all perfect crystalline solid is 0 at absolute 0 temperature. Okay? Now, this will now lead us to what I have as what? The Gibbs free energy. Okay? The Gibbs free energy is also a state function. The Gibbs free energy is a state function because it depends on the initial and the final state of the system. We started with enthalpy, we moved to entropy, now we are on Gibbs free energy. Now the Gibbs free or the free energy as well as the entropy determines the spontaneity of reaction. So before I proceed with the formula, spontaneity, let me talk about spontaneity. Okay? Now, starting with entropy, which is our delta S. When delta S system is greater than 0, okay? When delta S system is greater than 0, that means positive value of delta S. Is that taken? Values greater than 0 is said to be positive. The reaction is spontaneous. Spontaneous. Okay? It means reaction is spontaneous. Now, when delta S system is less than 0, it means the reaction is non-spontaneous. Spontaneous. Okay? So values less than 0 are said to be what? Negative values. Okay? When delta S system is equal to 0, that's a reaction at what? Equilibrium. Equilibrium. Okay? That means the reaction is at equilibrium. Now, the other state function that is used to determine spontaneity is the free energy. Okay, the Gibbs free energy. It is actually opposite of the entropy. When the Gibbs free energy, when delta G system is less than 0, okay, when the Gibbs free energy is less than 0, it means the reaction is what? Spontaneous. It is a spontaneous process. Okay? When the free energy of the system is greater than 0, it implies what? Non-spontaneous process. Non-spontaneous process. So after your calculation, you may be asked to determine the spontaneity. So non-spontaneous process. And when the free energy is equal to 0, it means reaction at what? Equilibrium. So if this is clear, type makes sense in the comment section. If the expression on the board is clear, type makes sense. If the expression is clear, type makes sense. Type makes sense if the expression is clear. Okay, makes sense. I need to charge my device. Can you still hear me? Please indicate, can you hear now? Can you hear me? Can you hear my voice? Please drop in the chat if you can hear me. I'm trying to check if we are still connected with the device. Indicate if you can hear me. Yes, okay. Now, if you are asked to determine the change in free energy, see change in entropy of the reaction. Okay, so all you have to get the free energy of the reaction to find the enthalpy of the reaction as well as the entropy of the reaction. Then the temperature of the system will be given in the question. Okay, just like the way we did this. Okay, so all you need to do is to find the enthalpy of reaction as well as the entropy of reaction. Then you multiply the entropy of reaction with the temperature of the system in order to find the free energy. Okay, we don't need to take question on that. It is exactly the same way we did this. Okay, so the next we need to consider now before we go on our show. So the 30-minute break will be reduced to 15 minutes. Okay, so that we can take the organic class. But you need to confirm to me if we should proceed or not. Okay, after we are done with the solubility. Now, another thing you need to know is that when we're talking about the reaction, we said the enthalpy of formation of an element is equal to 0. Then the free energy, the standard free energy of the free energy is in conformity with enthalpy by the entropy of an element is not equal to 0. That's again. So if you are okay with the expression on the board, we're moving to solubility. So I'm suspecting that for your exam. So solubility product. If solubility product in the chat. Solubility product. Solubility product. If you are on solubility, type solubility in the chat. Solubility product. Solubility products. Type solubility products in the chat. Can you hear me? Please, I need to know if you can hear me. I need to know if you can hear me. Let me know the condition of the microphone. Can you hear me? 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 I can hear myself right here. Yes, am I audible enough? Type. Should we proceed to solubility product? Response from Ascend. Should we take a break or proceed to solubility products? Take a break, proceed. Type in the chat. Yes, I'm very ready to proceed, but I need to confirm if you guys would like to have a break or we proceed. You know me, I'm a born teacher, so I have the energy to even take this class till dawn. Should we proceed or take a break? You want us to proceed? Write solubility products in the chat. If you want us to proceed, write solubility products in the chat. Solubility product, just drop solubility products in the chat. Ascend if you want us to proceed. If otherwise, type take a break. The number of participants is actually dropping. Or let me say it is fluctuating. If you want to proceed, type solubility products in the chat. That's the next and the final part of our physical chemistry. The final part of the physical chemistry is the solubility products. Yes, take a break from Ascend. We have a new participant. Gladys, Chika. You're welcome. So it seems Chika is here to substitute those people that would like to take a break. You can't hear me. Chika, can you hear me? Am I good enough? Okay. So to solubility products. Now, solubility products is denoted as KSP. Okay? KSP. KSP, which is the solubility product, is the equilibrium constant of Can you hear me now? Please indicate if you can hear me. Indicate if you can hear me. All right. From Rosier. You're welcome on board. I think I'm just seeing that name. All right. So this is clear. Then SP for this soluble Ag plus. So the coefficient right here 1, so we don't need to indicate the exponents. And Ag plus, and that's what the minus there. Can you hear me properly now? I'm trying to avoid the background sound echo. Can you hear me properly now? I'm not making use of the microphone again. Can you hear me properly now? All right. So we are talking about the sparingly soluble salts. We've considered the aluminum sulfate right here. I've been able to express the ionic species for the dissolution of the aluminum sulfate. I've been able to express the dissolution of silver chloride. We have Ag plus and the Cl minus. Then we have to determine the KSP expression, that's the solubility products. We're going to write the solubility products in terms of the ions present in the solution after the solution. So right here we are having aluminum 3 plus, so the coefficient is 2. So I'm going to raise it to the exponents of the what? The ion, the aluminum 3 plus. Then the sulfate right here, the coefficient is 3. So we are going to have the exponent what? 3. This is the KSP expression for the aluminum sulfate. Okay? So, can we proceed? We have a question right here. What are the factors that affect solubility? What are the factors that affect solubility? Factors that affect solubility. So you will be asked to give Three factors that affect solubility. Factors that affect solubility. Okay? So the first factor that we are going to consider is temperature. Temperature affects solubility. Is that okay? The next factor is common ion. Common ion. Common ion affects solubility. I'm going to explain this. Also, the pH of solution. pH of solution also affects solubility. Now, what is common ion? We have to consider these effects when you're talking about common ion. Let's say, for instance, we are having silver nitrate as the solvent. Okay, this is silver nitrate as the solvent, and the sparingly soluble salt that is being introduced into the solvent is silver chloride. So if the sparingly soluble salt is silver chloride and we are introducing it into a solvent which is made up of what? Silver nitrate. You understand? Now, there is a common ion there. We are having AgCl, which will give what? Ag plus Cl minus. Then, when we have dissociation of silver nitrate, it will give us Ag plus what? NO3 minus. Okay? Can you type in the chat what is the common ion in this solution? Type in the chat what is the common ion in solution. What is the common ion in solution? What is the common ion in solution? Can you drop that in the chat? What is the common ion in solution? What is the common ion in solution? Can you drop that in the chat? What is the common ion in solution? Then we take the last part. Is anyone following? What is the common ion in solution? Is it that you cannot hear me? If you cannot hear me, indicate in the chat. We can't hear you, indicate in the chat. Can you hear me? Indicate in the chat. Can you hear me? Indicate in the chat. So you can include presence here, okay? We have presence of common ion. Okay, presence of common ion. So the common ion in this solution is the silver ion, Ag+. Okay, we have common ion is silver ion. What if we have the solution of sodium chloride in a solution that contains, let's say we have in a solution of, we have the solution of sodium chloride in water. Okay, do we have common ion in this? Sodium chloride is actually soluble, so don't let me use sodium chloride. Let me use silver chloride. Okay, that's a sparingly soluble salt. So when you dissolve silver chloride in water, silver chloride will split to Ag plus Cl minus. So silver chloride will split into Ag plus Cl minus. So from here, we are going to have water. Water will give hydrogen ion plus what? Hydroxide ion. Okay. So do we have common ion here? No common ion. Okay. So no common ion in the solution of silver chloride in water. Okay. So we are going to treat a question now, but I need to know if you are following. We are going to treat a question now. Indicate if you can hear me. Indicate if you can hear me. Can you hear me? I hope my students are not sleeping. You are online, but you can't, you are not responding. All right, let me just finish this up. So what's the factor that affects the factor that affects the numerical value of KSP? So if you are asked to give the factor that affects the numerical value of KSP, the factor is just what? Temperature. Only temperature. Out of these three factors, only temperature affects the numerical value, the value of what? Solubility products. Okay. Indicate in the chat if you can hear me. Okay. Indicate in the chat if you can hear me. You're welcome. Shaman from India, you're welcome on board. Can you hear me? Indicate in the chat if you can hear me. I'm not making use of the microphone at the moment. Shaman from India, indicate if you can hear me. All right, clearly. Now we are going to take a question on solubility. Let's take a question on solubility. If you are just joining us, make sure you subscribe to the channel so that anytime we are having a class like this, you always receive notification. Okay? So, and make sure you share this video lesson with your friends. Share this video lesson with your friends or classmates, okay? Now we have a question right here. In the equation below, Ag2 CrO4, that's silver chromates, okay, was split to give 2Ag plus CrO4 2 minus aqueous. And here is our sparingly soluble salt. So you have to calculate the solubility. Calculate the solubility products. That's KSP. We have to find the KSP of silver chromates if the concentration of Ag plus is 1.5 times 10 raised to power minus 4 molar. This capital M implies mole per dm cube, molar. Okay? So remember I said the solubility product is expressed in terms of what? Molar concentration. So we have the ionic equation right there for the dissolution of the sparingly soluble salts. Is that okay? Now we have the concentration of the Ag plus is 1.5 times 10 raised to power minus 4. If you are following me, type "I'm following" in the chat. If you are following me, type "I'm following" in the chat. If you are following me, type "I'm following" in the chat. If you are with me, type "I'm following" in the chat. Okay. All right, I will need you to do the calculations for me. You press your calculator because I'm not with a calculator right here. So we've seen that the silver ion has the solubility 1.5 times 10 raised to power minus 4. Okay. Now from the expression right there, we have Ag plus equals 1.5 times 10 raised to power minus 4. Okay. And from here, we need to determine the solubility of the ions in the solution. Okay. So we need to find the solubility of individual ion in solution. So from here, I have 2s. Let S represent the solubility of the ion. And since we do not have any coefficients here, this one is S. Is that okay? So that implies that the solubility of the silver ion given here is for what? The 2s, because it is for the entire silver plus that we are having here. So the concentration given is for the what? Entire silver plus right here, Ag plus. So the concentration of Ag plus, that is the entire, in the entire solution is what? 1.5 times 10 raised to power minus 4. So what is solubility? The solubility of the individual ion in solution will be what? 1.5 times 10 raised to power minus 4 divided by 2. I hope you know why I'm dividing. Okay? I have to get the value of S from here. Okay? So this will give 7.5 times 10 raised to power, that is 10 raised to power, is that minus 5? Please confirm. Confirm. Please confirm this value, 7.5 times 10 raised to power minus 5 molar. Please confirm. Type the correct answer in the chat. Is that value correct for solubility of individual ion? 7.5 times 10 raised to power minus 5, is that correct? Seven point five times 10 raised to power minus 5. When you divide 1.5 times 10 raised to power minus 4 divided by 2, is that correct? If the value is correct, type correct in the chat. If the value is right, type correct in the chat. Okay, assigned. All right, let's proceed. So that implies that the solubility of the silver ion, the Ag plus in solution is what? 1.5 times 10 raised to power minus 4, because it has 2s. Okay? Why that of the chromate ion, which is S, is 7.5 times 10 raised to power minus 5. Is that taken? Can we write the KSP expression for this ionic equation? We have KSP equals concentration of Ag plus, we are going to raise the concentration of the ion to what? The coefficients as power, okay? Exponents will be what? The coefficients of the ion. So we have raised to power 2. Then this one, please, in the exam, do not write plus in between the concentration right here. It is the product. We are multiplying the concentration right here. So we are having that of chromate, CrO4, 2 minus. So what is the coefficient here? It is 1. So we don't need to indicate 1. So we have KSP equals, now the silver that we are having in solution, the entire silver that we are having in solution is 1.5. So we are having 1.5 times 10 raised to power minus 4. That's the concentration of the silver ion there. Square, okay? Then the chromates, we've gotten out of chromates since it is S. I will introduce 7.5 times 10 raised to power minus 5. Okay? So what is 1.5 times 10 raised to power minus 4 squared? Then we multiply it with 7.5 times 10 raised to power minus 5. Can you drop that in the chart? .5 times 10 raised to power minus 4 squared. What is the value? Drop that in the chart. 1.5 times 10 raised to power minus 4 squared. Then you multiply with 7.5. What is the final answer? Please confirm this answer. We're having 1.69 times 10 raised to power minus 12. So when you multiply this, what do we have? 1.69 times 10 raised to power minus 12. Please confirm this answer. So what will be the unit of the solubility right here? Okay, since we have square and we have raised to power 1 here, that will be cube, right? 2 plus 1, that is 3. Is that taken? So we are going to have m raised to power 3. Okay, that's molar cube. Molar cube is also expressed as, molar is mole per dm cube. Okay, mole per dm cube. So if you now find the cube of this, so it will be mole cube per dm what?
per dm. 3 times 3 is 9 per dm 9. So the units of the KSP for this particular calculation is mole cube per dm 9 or molar cube. Okay. If this is correct, please confirm this value. If it is correct, type up. If it is correct, if this value is correct, type correct in the chat. If the value is correct, type correct in the chat. I hope it is clear how I got the units. Unit clear. If it is clear how I got the unit, type unit clear. Yes, I want to believe we're having 4 participants. Only assigned solution is responding at the moment. All right. From Ankit, continue. We are just seeing you in this live class. Where have you been? Ankit. You have lots of problem on more concepts. Please, after this class, make sure you go through my video lessons. I have several video lessons for the JUPEB students. Okay, you're going to check the playlist JUPEB 2026 videos. Okay, for general chemistry, I have videos for general chemistry. I have videos for the physical chemistry, organic chemistry, and the inorganic chemistry. Make sure you go through the video lesson. There is a video lesson on mole concepts where I explained everything on mole concepts. There is another video on stoichiometry. Check my video tab on this channel. You're going to see solutions to your problems. Is the unit clear? How I got the unit, is that clear? Type unit clear. Okay. Okay, unit clear. Now the time is 12:15 at the moment. 12:15 at the moment. I would like us to go on break. We stop our physical class right here. Then we can go on break. Then are we starting in 30 minutes time, or we should take some rest? Then we continue the class in the morning. Yes, around, and we continue the class by 6 o'clock. So we have 6 to 8. Is that okay by you? 6 to 8. Organic chemistry. We conclude so that we can conclude the organic chemistry. 6 to 8. Or we should just continue in the next 30 minutes. I have to charge my device also. 6 to 8, is that okay? Organic chemistry, that's chemistry 004. Please don't joke with this aspect of the physical chemistry that we've considered right now. Are we okay with the class? We continue by, okay, that's true, you have paper by 8. You have paper by 8. Ascend, you are from which school? You're writing your exam in which school? Which school are you? Ascend. Ascend Solution. Let every participant state your school in the charts. Okay, Lautech. State your school in the charts. Lautech, Ogumosho. So, can we make it 4 to, okay, 3, let's make it 3 to 6. 3 to 6. Is that okay? 3 to 6. I just pray I don't slip off. 3 to 6. 3 to 6 is okay. All right. So we end the physical aspect of the chemistry here. Then we'll continue by 3. So I'm going to reschedule the live chats for organic chemistry. So I will see you by 3 o'clock for organic chemistry. So do have a nice and wonderful sleep. Don't sleep too much. Your exam is tomorrow. All right, take care. Bye.